Now if I press up, our car should move. If I press back, it should move backwards. And it's going to hit on these things. Now, if I press the arrow keys, nothing happens because I have not implemented the steer component. Welcome back to Arcade. I am Super Tommy, and in this video, we're going to look at Kaboom.js and top-down car control. Very similar to this picture that you see here, where this car is at a top-down view, and then it can basically turn from that top-down view. Now, before we start, if you enjoy our videos, be sure to like and subscribe for more videos on making games with Kaboom.js and other web technologies. It is also the best way to support the channel. Now, let's get started. First thing, we are using the bleeding edge version of Kaboom.js in this video, which you can get by doing npm install Kaboom at next. Now, depending on when you watch this video, you may not need to do that because the Kaboom.js team have already released this latest version. We're talking about the version after v0.5, after version sticky type. So just check that in the version of Kaboom.js that you're using, and if it is greater than v0.5, you're probably using the one that we're already talking about here. But if the syntax is a little bit different, you should still be able to follow. The concepts should apply no matter what changes to the library are made. Right, first thing here, we're gonna move our car with two components. First one is the gas component. And so the gas component, what we're gonna do is allow the car to move forward or backwards in the direction it is facing. So if it's rotated this way, then forward is this way. If it's rotated this way, forward is this way. Right, and backwards would be the opposite. So that's what our gas component is going to do. And we're going to write that component and attach it to our entity, and it's going to allow that entity or that character to move when we use the up arrow key. Now the next thing is steering. So our steer component is going to let us basically turn the car when we use the left and right arrow keys. But in a car, you can only turn if you're actually moving forward or moving backwards. So it's going to leverage the gas component to know whether it's moving or not. And then if it is, allow you to turn the car. And if it's not, it'll do nothing. So let's see how we can code up these two components. All right, so we're going to use these assets from Kenny. This is the CarRed 3. This is from Kenny's game assets. It's a top-down racing asset that Kenny has. Kenny's got a lot of great assets at Kenny. That's KENNEY.nl. At his website. They're all free to use, and they're really pretty awesome. So go check that out if you need any other game assets. But right now, in this video, we're using this car and a cone asset to kind of show you how we can move around these cones. So let's go to main. We're gonna load our assets here with load sprite, car, and cone. And these are these assets we have in our assets folder. And then our vehicle steering component right here. We're setting that as our scene, or rather our not component, our vehicle steering scene here. We create our scene, then we start our scene with go. Let's look at our vehicle steering scene here. And there's a lot of functions we're going to use here, and these are destructured from our Kaboom instance. Now, if you've seen our other videos, you kind of know how our setup is. We have a Kaboom.ts file, or JS if you want, where we create a Kaboom context here, and we share that context in our game across our different files. And so what we do here is we create it in main, or we create it in Kaboom, then we import it in main, and then from main we get our scene and go and load sprite functions, call all that here. Same thing with our scenes. So here in our scene, we're going to use these functions from Kaboom. We've just pre-destructured it out. So in this case, you can also do, k.post or k.vec2, k.cam post, but so that we don't have to write k.all everywhere, we can just destructure them at the top of the file and then use it everywhere else without using k. Okay, so this angle to vec2, if you've seen our space movement video in Kaboom.js, it uses a similar function here. We're just reusing that so that we can get the directional vector based on the angle of our sprite. So we're going to need that here as well. If you recall, in our gas component, where you're facing is where you're going to go. So in order to know where you're facing, we need to get the directional vector from your sprite angle. All right, so in our gas component, this is all TypeScript type, and you can ignore this if you're using JavaScript. But let's look at our gas component here. We're just going to say our speed is 10, and we've pre-defined what we're going to want in our component. So update is something that is a built-in hook for any custom components in Kaboom. This will be called by Kaboom every frame. Anything else you add here will just be merged into our character or entity. So we want to know when we're driving, which is moving forward, when we're in reverse, moving backwards, and when we're either in reverse or forward. Either one doesn't matter. We want to know if we're moving or not. So how we'll do that here, this is stubbed, is by using detecting if the up key is pressed for drive, the down key is pressed for reverse, and if either is drive or is reverse is true, then is moving is true. So I like to do this in projects sometimes is I'll stub out the function that I'm going to implement. If I know I'm going to return a number value, a string value, a Boolean value, or an object or whatever, I just return some like a default value just so that I can set everything up and then go in and implement the actual implementation of that function. So in this case, we want key is down, up, and that's for gas. So there's no longer to do. And then for reverse, we want key is down, down. That's going backwards. And then for is moving, it is very simply if this dot is drive or this dot is reverse. If you're moving forward or backwards, you are moving. And so that's these three. Now in update, what we want to do here, this is gas, figure out which direction we're facing based on the angle of our car, get the directional vector, and then apply a speed towards that direction. And that's how we're going to move our car. So first thing, we need to know if we're moving. So let's say if we're going forward, this dot is drive. So if we're moving forward or we're moving backwards, we're not moving forwards or backwards. So this dot is reverse. So if not forward and not backward, return. So we're gonna do nothing in this update if we're not going backwards or forwards. You can of course just do is drive, and if not is drive and not is backwards, but either way. Now the direction we're gonna go is if forward, then direction is gonna be 1 for forward direction, and then -1 is gonna be backwards direction. So this is just for us to do math. Next. So now let's get our directional vector. We're gonna do angle to vector 2 based on the angle of our sprite. So this dot angle, which is gonna get from our rotation component. So let's actually go down here and show you our main vehicle steering here. So this is just the level that we've created. The car is this C. That's how we create our car. Right here, we have a rotation component on our car. We have an origin component, and we of course adding our gas and steer components to this car. But we have a sprite, area, body. And what's important here to note is because our car is top down, you're going to want to set your max velocity to 0 on your body so that it can still collide with our cones, which are these O's here. So we'll have collision without having Kaboom.js's built-in, which is side scroller centric physics, interfere with the collisions or with how our car is going to run. Our car is not going to fall down. It's in a top-down view. So that's what this max velocity is. So this is our basic setup for the car right here. And our camera follow component is very basic, just so that it'll follow the car here. So that's what our very simple camera follow component does. It on update just updates the cam position to the position of the character that has this component on it. Now it may not work so well if you put this on two things. The last one you put it on is probably what's going to be the one to work. So there's that, and these arrows are just going to be to show you when we're pressing the keys. So let's go back up to our gas component here. So we have a rotation component on our car. That's how we can get this dot angle. So without our rotation component, we really can't get an angle. So make sure that is attached to your car character or entity. So now once we have this directional vector, right? So it could be 0, 1, so which means it's going to be going down if that happens to be that direction. But in most cases, it'll be something more less round, right? Like maybe 0.83 comma 0 minus 0.1 or something like that, depending on which direction your car is turned in. So to move it, we do dot x plus equals the vector direction times our speed times direction. So if we're going backward, this will just invert everything and we'll go backwards. So this dot position dot y plus equals directional vector dot y times speed times direction. So that's our gas component. Now, if I can preview this, it should still work. Let me go to our preview screen here. Okay, so we have this set up. This is the arrow keys that I'm pressing, and you see it lights up at the bottom right corner. Now, if I press up, our car should move. If I press back, it should move backwards, and it's going to hit on these things. Now, if I press the arrow keys, nothing happens because I have not implemented the steer component, right? So that's pretty cool. So that's the map that you see that we created. Okay, let's go back to the code here. So now let's implement our steer component. So let's come down here, steer. So if you remember, steer is very simple. All it does is allows you to change the angle of your sprite if you're moving. So now we are assuming in our steer component that we have a gas component attached to this character. Now you could do a check. So what you would do is if this dot is moving, like if you want to do a check, you would do is moving and this dot is moving. So that means we are moving. So if we are moving, then we can do this dot angle. We're going to test which key is down. So first, if is key. Actually, let me check. Yep. Key down. The key is down. Key is down left. So if the left key is down, we're going to want to, I think, subtract. Let's just say -3. And else this dot angle +3. So we're just going to change our angle by plus or minus 3 if we're left. Actually, don't want to do else. If key is down right. So if we're going left, -3 degrees every frame. If we're going right or pressing right, +3 degrees every frame. So let's see how this feels. So forward. Oh, that is wrong. It thinks left is always pressed. That's funny. Okay, let's see. Let's see what we did wrong here. Back to code view. Okay, let's see what we did wrong here. Okay, else if. Okay, so it's always right. So it's constantly pulling me to the right. Okay, so let's go back to our preview here. Make sure we did the right thing this time. Okay, here we are. Let's move forward. Turning right, turning left. Terrible driver. Here we go. Let's go around this course. So of course you can make a racing game like this, Destruction Derby, whatever it is that you kind of want. Snazzy. Let's go reverse. So one thing with reverse, that this is going to be a matter of feel, I think, depending on how you feel like the car is going. Let's go back to our code. So when you're going backwards while you're steering, it may feel weird, like the left is actually going right or right is going left. One thing that you could do is, I'm just going to copy this over, is to change direction depending on whether you are moving forward or not. So if you are moving forward, that's drive, normal direction. If you're going backwards, that just invert it so that it feels a little bit different. So that's just times direction over there, times direction. So let's see if this feels any different. And now let's go backwards. To me, this maybe kind of feels better. So I kind of change my mind depending on what I'm doing. Sometimes when I'm demoing it, this feels right. Sometimes it doesn't. But anyway, that's one way you can do to change the like feel when you're going backwards, to basically invert what left and right is. Now, another thing you can notice here in this demo here with Kaboom is this collision is going to work correctly, right? You see the car doesn't really go past the cone. On the other hand, like that, here, you see that my car has gone past the cone. So the problem here is Kaboom.js, the built-in physics that they have is not axis aligned, meaning when we rotate the car, and now that it's rotated, the hitbox is really still the car like this. Right, so that's why this is good, but if I rotate into here, it's not, because it's still on that rectangle. That non-rotated rectangle is what the collision box it is using, and so that's why it looks like that. Now, it may not matter for you depending on what kind of experience you're making, or if your cars still happen to be a square instead of a rectangle. But if you're making a prototype, that may not matter. One thing you can do is use Matter.js, and we do have a video for how you can incorporate Matter.js with Kaboom.js. So that'll be how you can do an axis-aligned collision and physics with your Kaboom.js renderer. All right, so that's our car control, top-down car control in Kaboom.js. We got our gas component, our steering component, so that we can do stuff like this. Now you can make your own racing game, destruction derby game, whatever it is. The physics is a little bit wonky, as mentioned. The axis is not, they're not axis aligned, the collision boxes, but you could use Matter.js like I mentioned. And so if you enjoy these videos, be sure to like and subscribe for more videos on making games with Kaboom.js and other web technologies. Thanks for watching.